Before I did the analysis of a single variable on a file that I imported, that's not a very interesting analysis. Most datasets you're going to have are going to have more than a single variable. They're going to have multiple columns and they're going to have different types of data. So it won't just be scalar data, there'll be a mixture of scalar data and categorical data. So in this case, I'm going to use a more complicated dataset. So if I go to open, I could open the Iris species CSV file, which I've got there, but I'm going to use the data library version that actually comes with the program itself. So there are files for meta-analysis, so you can practice on that. But the one that I'm going to look at is Anderson's Iris data, sometimes called Fisher's Iris data, which is a bit unfair because it was collected by Anderson, though it was now analysed and given its high prominence by Fisher. What you have is 3 different species of iris: setosa, versicolor and virginica. And what Fisher was trying to do was look to see if petal length, sepal width, sepal length and petal width could be used to distinguish between the different species. So here, the key thing that I want to do when I summarize the data is not summarize it all together as one group. I want to summarize it so that I have a different mean for each of the different groups to see if there's any kind of differences. So when I go to exploration and descriptives, what I've got here, so let's say I look at sepal length. Now if I just click on that to start with, there's 150, mean is 5.84, 5.80 is the median, standard deviation is 0.828. I can also do some plots, so I can do the histogram and box plot because it's continuous data. Now the histogram already suggests something because it suggests there's a peak and then there's another peak and then possibly there's a third peak. When I look at the box plot, there's nothing particularly interesting in it. The median's fairly in the center of the interquartile range. So what happens now if I decide to split the data? I'm going to split the data so that I have the averages and the summary statistics done based on species. So species is the splitting variable. It's a categorical variable, is the thing that's always needed for splitting things. Now, the second I've done that, I've got a much more interesting descriptive table. There's 50 of each, which is good. There's no missing data. The mean value for setosa is 5.01. The mean for versicolor is 5.94. The mean for virginica is 6.59. There are medians and their standard deviations. Now, I showed before, and something that's important here, is the standard error of the mean and the confidence intervals. So when you're looking at the confidence intervals, what you want to do is look to see if the confidence intervals overlap. So the confidence intervals for setosa goes from 4.91 to 5.11. For versicolor, it goes from 5.79 to 6.08. These two confidence intervals do not overlap with each other. So there is a difference between setosa and versicolor in their sepal length. Then you go for versicolor, it's 5.79 to 6.08 and virginica is 6.41 to 6.77. So again, they do not overlap with each other and they can be distinguished. Now if you look at the actual plots, because of the amount of variation, so although the confidence intervals don't overlap, because they're not perfectly sharp normal distributions, there is a certain amount of skew and a certain amount of overlap between the different species. So there's a case of a virginica which has a particularly short sepal length which overlaps strongly with versicolor and setosa. So you can't completely guarantee that there's a difference, and this 107 is an unusual value. But if I look at the box plots, I can see that there's not any overlap between the interquartile ranges of the first two and probably the last two. Just about. Which means that sepal length is a good way of distinguishing between the different species. If you go on to look at artificial intelligence methods, the Fisher dataset was one of the early methods that was used for assigning things to categories using artificial intelligence methods. It is one of the sort of gold standards in use for analysis. It's not so important now because it is a trivial dataset compared to the ones that are used in deep learning these days. But it is a good example of the processes needed for machine learning and artificial intelligence.